Hey everybody, welcome to the next E-SIG meeting, which is the European US conversations. Thank you everybody for coming along. It's going to be an interesting call, I think, because we've done some thinking on the E-SIG side. We've started to write down some of our ideas. We put that down in a document, which I shared Friday, I think, or over the weekend anyway. So we got it up. I know it's still relatively fresh. Luke, thank you so much for your feedback and enthusiasm and positive energy in there. It was really awesome. So we've got some thinking to do on what that looks like. And I'm sure there's going to be a whole bunch of questions and answers and some corrections to assumptions. But that's what we're here for, is to talk it all through. So I guess that's going to be the main topic of the conversation today, is that document. And I'm going to basically open the floor to comments and questions about it. Particularly Luke, I guess, because you've had the chance to have a look at it. And I tried to get back to give some feeling for what we were thinking. I know I'm not the only author of that document. There are others. So this is probably the right place to go through some of that feedback and some of the questions and answers on it. Has everybody had the chance to read it? Anybody got any questions on it? I can post it to the comments, to the chat as well. So we've got a record of it. There you go. Here's the link to the markdown. And there are some issues which are all related to it, which you can find here. If there aren't any open questions right now, I'm happy to go through some of the Siemens perspective on it, on where we are with it. So a lot of this for us is as much about the standard as it is about business continuity. We have a world in which there are people paying mortgages with WebAssembly, which is great, and with WASI, predominantly the Preview 1 runtime. And for us, there's a need to make sure that that continues. We need to do that. The work on the component model sounds promising, but is not there yet. So how do we move forward and still allow time for the component model to mature? Because we can't adopt it right now. So how do we get that business continuity and still be open for some of the advantages that the component model brings? Because we like it, has some cool ideas in it. We just can't use it right now. So then the thinking was, let's do something where we know when we talk to people, I've talked to folks, folks on this call and beyond, and I've talked about the need to continue support for Preview 1. And the feedback I get from various points is, hey, that was a prototype, it was an early preview, we shouldn't build a product on it. And the unfortunate reality is that boat sailed, people have, and there's mortgages being paid by it. So in that regard, there's a need for the embedded community to effectively step up and provide that business continuity. And I think you see that in the document when we call out in the gap analysis of where we are today. Not where we hope to be, but where we are today and what we need to do. And so it's like, hey, we're going to have to support this. We're going to have to do something about it. And it's up to us to do it because there's nobody else coming to provide support for Preview 1 going forward. And a lot of the gap analysis goes through that in a good bit of detail, I think. It starts to explain what we need and where we are. So with that, we go, okay, let's continue to provide support. And then the conversation goes to migration strategies. Today, we have preview one runtimes burnt into ROM images that can't be updated by some of our embedded colleagues. In the future, that's likely to be true too, while we wait for the component model to mature. So we're going to need some method in the future where if something comes from the component model toolchain that we want to use, we can use it in some way. And there are promising signs that there might be options for that, and we don't want to close those off. So it's a need for continued support for preview one, and to make sure that we've got the space for the component model and for preview 2, 3, and the release candidate to mature and get to the point where we can use it. And in the meantime, we've still got something that helps people pay their bills and helps product ship. And that's the round peg in a square hole, I guess it really is. We're trying to a square peg in a round hole. It's the difficult problem we're trying to solve, and there's no easy solution to it. And I think in the document we go through some of that. There are some design considerations that are brought up in the design document too. We talk about, given the fact that most of the system, software based around preview 1 or 0.1 as we called it, most of that software is C based. It has a POSIX-like interface. We kind of need to support that. And we're going to have code which expects the low-level types of primitives that POSIX supplies, and we're going to need to have those around. Then there is some discussion in the document about, well, does it make sense to try to reverse engineer the low-level primitives of POSIX that we're going to need in the future and today from the high-level constructs we start to see emerging in the component model? And there's some design discussion about how that would work. And there's some discussion about avoiding confusion between this business continuity effort and about the component model and the more high-level application architecture structures. And there's some brainstorming on that in the document. The document's not written in stone, but it's an open point for discussion. So I hope that gives some context for what I think the document, when I read it, from my perspective, is trying to achieve. I don't know, Stephen, if you've got anything you want to share on that, because I know you're a major contributor to that document too.
Sure. Sorry, I'm taking notes. I'm letting you talk. No, I agree. I think, one of the things that we're struggling with on our side is how do we support a lot of the industrial embedded customers that are looking at at this today, and how do we provide support for the legacy code base they have, right? And I think you articulated it well. Commonly, you'll see some sort of low-level system interface, right? Kernel syscalls, libc, that kind of work. That's the core support that we need. A lot of that is already existing in WASI P1. If you add some of the extensions that we looked at, networking threads, that kind of stuff. And that goes a long way. But I think there's a gap there that we need to fill. There's a couple of things we articulated in the document. Maybe formalizing a little bit more about the threads, something around signals, right? Because that's needed for a number of things that really need to be put in place. And I think we could close that gap in pretty short order, enable this to move forward, and then at the same time, not stand in the way of what's going on with the component model. I think there's an eventuality there where these worlds likely will come together. But that does appear to be a ways off. And I think, we have a window of opportunity where there's a lot of folks really interested in using this technology. But if we don't provide some sort of path forward, then we're going to lose a lot of folks along the way, right? They're going to go elsewhere. They're going to look for different solutions. They're going to they'll build their own custom solutions on their own, which is sort of counter to what we're trying to do here. So I think our goal here is there's a lot of goals here, but I'd say two things on my side is how do we figure out how to support what we have now and the few things we need in the short term, and then what do we need to do in the long term to make these two worlds work. So
Yeah. Ralph had a question.
Don't know. Can you hear me? It's hard to know.
Yes.
It's a miracle, frankly. Yeah, no, I don't really have a question, but I did read the document to be sort of two things. We had worked hard to get target systems up that we could shoot toward with the component model, and we have to achieve, approval for those target systems in order for the component model to be useful to anybody, right? Like that's the exact reason we had that document. So I was confused by the conversation about the component model in the document. Whereas the opening here, Chris, that you've just sort of laid out quite well makes complete sense to me, which is like, what do people do between now and then? And I think that framing alone makes the document, like, okay, great, let's figure out what we're doing between now and then, right? So I don't know if that was really a question so much as that really clarifies to me what's going on. Getting for businesses to get, somewhere before they get enough out of the component model where they just go, yes, this is actually the thing we've got to do. That's the kind of conversations businesses have to make all the time, right? Like, so that makes complete sense to me. So with that in mind, if the document is focused on what do you do until a plausible component model arrives, then that would make complete sense. Like I wouldn't even say anything else. Like that makes complete sense.
Luke?
Yeah, I also like that framing that you said, and then Ralph reiterated. Particularly if we subdivide, there's a first problem of we've got shipping preview 1 engines out there baked in ROMs. How do we? They're not going to change, but how do we keep the producer tool chain that emits code that runs on them maintained? That's I think the easiest to get lots of people to agree on. I think the WASI group as a whole has agreed on that for like a year. So, and this is the right group to actively work and maintain those. How do we produce code that runs on existing preview 1? And then, so that's the easiest part, I think. And then the next part is, okay, the transition between now and a stable component model, which obviously is, yes, takes some time to address things still in progress. What do we do in the transition? That's also a good framing. That's a good problem statement. I thought you opened well with saying that. The document doesn't quite convey that. I would say what I got from the document was we're not sure if the component model is going to work out. So we want to kind of do a wholly separate thing that it says is layering, but I don't think actually there's any layering for what was proposed in the document. We're going to kind of start with preview 1 and then add a bunch of things that go in this direction. Ideally, the way one transitions to a thing is you say, okay, that's the goal state. Let's trim as much off of it as we can to get a thing that works in the short term, that minimizes work for core engines to adopt in the short term. And then, if there's a stopgap, how can we add a few little placeholders that we need? That we will have them, but let's figure out a short-term quick fix. So that sort of framing is different, and I think I'd be happy to contribute to that. How do we minimize the effort to get a thing working in as short a time as possible that works on existing core engines? That's a thing I was working on. I didn't see any of that sort of engineering proposals in the document, but I would like to see them. And I think the higher level framing of we want to transition, but we need to ship a thing in the short term that works with existing core engines makes sense.
Yeah, I think obviously from these existing standards processes, this effort of web development methodology of we're going to just stop work on that old one and move on to the new one, and it works really well in the web. But here we struggle with that. It's more of a platform building problem, as Ralph said, a business problem where we've got people using it, and that transition just isn't as easy to make. So it's filling in that kind of gap. And you're right. I mean, I think from a technical point of view, Stephen did some really great thinking in the document, and I liked it. I think we're trying to ask those questions. There are gaps missing in preview one. How do we fill those in a way that makes sense for the component model when it comes? And hence you see the layering discussion of, hey, maybe we've got this low level primitive, let's do it here, and maybe it could be used there, maybe. But we don't want to hamstring the component model by doing this. So there's kind of a bit of a discussion in the document, I think, where it says you don't have to use it, but you could, and it might work. And that's where we're kind of, the juggling's happening of like, how do we make this happen? So yeah, and I think from a gap analysis point of view, tried to be really stark and transparent with people. I mean, this is where we are. We don't have these things yet. There's a lot of promising engineering, but it's not there today. So what do we do? And that's the motivation, I think, behind a huge part of that document was just being transparent, because there's a lot of really cool ideas in the component model, but they're cool ideas that take a lot of engineering effort to achieve, and they will take a lot of engineering effort, and they will be cool when they come, but they're not here yet. And there's been a pause on preview one, and we've still got those gaps that we need to fill, and that's where the tension's coming. Like, hey,
yeah, and I think the key here is a successful incremental approach will avoid creating kind of a fork where there's a bunch of effort in this direction and a bunch of effort in this direction, and there's no shared benefit. In that case, they might as well be just totally separate standards. They're just unrelated in the same way that, WASI is unrelated to, proxy WASM or WASIX or, WALI or any of these other things. Those are just totally separate. All the engineering there is cool. It just doesn't contribute to WASI or vice versa. So the trick to finding a good incremental approach is to figure out how are we both addressing a short-term need, but also going in the direction of the long term, so we don't have to either throw away work or just go off on separate forks and never meet, which is usually the way forks go if they go long enough.
Yeah. I think I've talked for long enough. This hand's been raised. I see. The tool says it's Marcin plus one other. So I'll go for Marcin first.
Yeah, it looks like I was first. Yeah, I have a really question to Luke. I just want to know your opinion because I don't think that was discussed, and I think it would be good to get your insights on this layering approach, because we discussed this for some time, and it at least it feels to me like quite a reasonable thing because essentially when you build a component model, under the hood there is this canonical ABI. And I wonder, why don't we have a standard on that level, standardize those interfaces and then build component model on top of that. So for example, taking a socket API, in this world where we have those two standards, one built on top of another, there could still be the lower level API, canonical ABI-like or P1-like API for accessing sockets. And then on top of that, we build something like what we have today defined in WIT. But there will be two separate standards. There will be dependency. The component model in those cases will depend on those low-level APIs unless there's some emulation implemented in other way. So I really want to know your opinion on that. What do you think? Why do you think it's a bad idea? Or maybe you think it's actually a good idea?
Yeah, I do like that idea. That is the approach I like. The crucial technical bit is this. When we write the low-level core WASM API, is it just an ad hoc thing where a human just says, I'll take a pointer here, and then maybe it'll point to this, and maybe it'll point to this? Or do we derive it mechanically via the high-level types? And this is what enables binding generation, which is what's this huge, especially as a person working in a company who's been maintaining a platform with ad hoc handwritten APIs for quite a few years. It's very error-prone. It's very laborious. What we'd like to get to is a world where we have automatically generated, derived ABIs with automatic bind generation. If you want it, you don't have to use it, but if you want it, with obviously high performance, which is just as good as performance as if I'd hand coded. It's just done in such a regular way that I can automate binding. So that is the approach I would like to take. I don't know if that exactly aligns with what you were thinking, but what I just said is how I see kind of reconciling those points.
Yeah, no, I do agree with you on that part. This is something that I struggle a bit when I saw the component model and the with interfaces for the first time, and I think I might be a blocker for adoption going forward. Is that when I see with definitions, I'm not quite clear how is that going to look like under the hood, right? It's not clear where are the copies, where are the allocations, and even if we, I think, provide really extensive documentation, there's going to be still fairly high bar of getting up to speed with that. Whereas I think industry, especially the embedded industry, is very familiar with those primitives. I see a pointer and I see a size of that pointer, so I know, oh, okay, I need to allocate a buffer or something like that. And I think a lot of the people from the community, even though we all understand the safety implications, the fact that it's error prone, they probably would appreciate having those sort of definitions. And then if people, for whatever reason, for good reasons, actually for safety reasons, for example, don't want to use it, they go for the width definition and use that. So
yeah, I mean, I think a C header file is a great thing that a lot of people are familiar with. I think we could, the key would be to generate that from the widths. So that way you can, again, when things are written in a hand way, there's no correspondence with the canonical ABI, and then somebody in somewhere has to write a manual adapter. So like the preview 1 to 2 adapter, that had to be handwritten because it had to take existing ad hoc ABIs that were in preview 1 and adapt them to canonical ABI. So that has performance overhead, has complexity overhead, and it's a lot of work. So the idea is to avoid all that work going forward, saying let us code gen, derive our ABIs. We can get a header file, and this is the thing I think a lot of people would want, and it's just a bit of tooling. I think there's even existing header generation. What's missing would be some nice documentation that sort of says this is a pointer to a struct, with this layout and that sort of thing, which is incidentally kind of the hard thing you have to deal with in any case when you're writing to a bindings. You have to learn what the structs are and what the layouts are and exactly what the lifetime management. So in some sense, this is the essential hard problem in any case when you have like more than like numbers.
Yeah, I think the sort of tooling that immediately, almost as I write with, translates it to the C APIs with a nice documentation will probably address part of the problem. Another part that I wanted to discuss with you, but I see Thomas had a raised hand, so maybe I should wait with my next question until the queue.
And
takes a
Dan's
round.
gone up too. So you go raise your hand now, and then we go to Tom.
Yeah, I'll raise another hand.
No problem, Marcin. Just fine. You already told what I needed to say, so that's just fine.
Okay, cool. I see Dan has a raised hand as well, so.
Yeah. And sorry, guys, no video because I'm actually on vacation. So, yes. Greetings from Spain. So the only thing I wanted to add here is that I think we've discussed this, maybe not in the whole group, but at some point, the idea that the bindings, the raising and lowering code could be a build time operation rather than runtime. So in other words, like from the developer point of view, you write, such and such code, it gets compiled into, let's say, the component model that's targeting this canonical ABI, but that could have an adapter underneath that is inserted in a build time operation or a post build operation before actually getting run on the runtime, which perhaps would be a preview 1 or such. Is this making sense? Is everybody with me here? In other words, those adapters could be something that's the runtime is providing, or it could be something that's a build time operation. And I think for certain use cases, at least from our point of view, that's totally fine. It's not a problem because we do not expect write once, compile once, and run anywhere. Not necessary.
Yeah, it makes sense. And I think Luke and I spoke last week in San Francisco. We were going through this, and that was my questions, Luke, at the time about if you could do J-code to transpile the component model today to run in a cool WebAssembly environment that just happens to have a JavaScript host, which is the web, then it might be feasible to take that same approach and say, well, hey, we could maybe do this translation and transpilation to have something that would run in a ROM-based bound core WebAssembly engine, which just happens to have a C-like POSIX interface and host instead. So that was the discussion I think Luke and I had in person over a beverage or two, but it was rather quick. It wasn't in any great detail. I did talk to Joel Dice about the whole idea too, and he backed up what Luke said. Totally feasible. There's engineering effort required, of course, but it's a feasible approach. I'll shut up now. Next is I think we've got Stephen, and it just says one other hand, so I don't know who else is up. Marston's probably up there too.
Marston, did you have something else you wanted to say before I go?
Yeah, actually, I wanted to touch on the JCO and the transpilation because that's what I wanted to briefly discuss. If you don't mind, Stephen.
Nope, go ahead.
Cool. So yeah, on that part, because that's where I see the tooling is the direction the tooling is going overall is that the sort of the first class citizen is the component module in WASI SDK and potentially other tools as well. But the way I see the component model is kind of like a decoration of the core WASM module, right? So one thing I wanted to discuss, and I'm not sure if this is the right audience, or maybe we should talk about this with the tooling people, is whether this is actually the right direction, because it feels to me like we going around, generating a component module, which is more complicated than a core module, and then we building something that strips the component model part from the core module, whether it's a transpiler or something else. Whereas why don't we say that a core module is the output of the tooling, and then if you want to have a component model, here is a tooling to sort of decorate the core module with all this stuff. So do you think that this is the direction we should go when it comes to tooling, or are you against that? For what reasons?
Yeah, that's a really good question, because I see the seeming tension, because so in one sense, yes, to what you just suggested, and that there's even a PR up on the component model which describes this. Could I emit a simple core module via the toolchain, and then it's an optional follow-up step to wrap it into a component. And if you don't want to wrap it, you don't have to. That works, and there's, toolchain people think this is a good idea. This can actually simplify the lives of these of like the LVM compiler, of the Go compiler. They don't even know about component. They're just emitting core WASM, business as usual, and then it's only at the final WASM component LD stage that you wrap it up. So that does work, but it comes with limitations. And the limitations, you could say, is one, if I wanted to have multiple core modules, like I wanted to separate out a common runtime where I can share the machine code and then the application specific code, I can't do that because it's just one. That's one limitation. The second one is if I want to have two components with two separate memories, which not everyone does, but if you do, there's lots of use cases. There's no way to support that at all. So for that simplest case, though, that's one good idea. So that's on the producer toolchain. And so a producer emits a core module, hands it to a core runtime that implements exactly that ABI, it runs. So that is one thing that can work. It doesn't capture the full expressivity. So the question that we've heard as a response to this proposal is, but what if I did want some of those things I listed? Not everyone does, but it would be, some people are like, it'd be sad if embedded depended on this, if embedded was like, limited in capacity compared to the same component I could run in all these other environments. I can't run embedded. What if I did want that? So that's where the second step comes in, which could be complementary to the first one, which is the JCO approach, which is when I have a component that's doing something interesting with multiple core modules, multiple components, multiple interesting things, all that components are doing is just decorating, as you said. It's just saying how to link together, and also what are the different ABIs. I neglected to mention that point earlier, but when you have just the one core module, you only get one ABI. It's all 32-bit or all 64-bit or all WASM-GC or all UTF-8 or all UTF-16. The component lets you kind of say which one you want. And so instead of forcing everyone to do just one thing. So when I want to take advantage of this flexibility, the JCO approach lets me code gen just little glue WASM. So it's just core WASM, but it's not the WASM that I initially compiled. It's the glue stuff that sits either in between WASM and the host and WASM, or between WASM and WASM. Basically, all the trampolines that take you in or out. The JCO approach cogens that stuff into more core WASM. Once you have all that core WASM, you can smush it all together into one module that maybe uses multiple memories and hand that to a core WASM engine. So that's the approach that Chris was talking about, that we talked about. I also talked to Alex a lot. He actually started to be pretty excited about the idea, saying, oh, maybe we could even actually use that as how we implement the component model in WASM time. So it's like very well tested. And we use it with JCO, and we use it with Apico, and we use it with, like we use it in a lot of places. So it becomes this like, well-tested piece of common software. That is when you want to take full advantage of all the things the component will let you do that simple one core module of WASM wouldn't let you do. So it's sort of like a two-part answer.
Yeah, I understand. So yeah, I understand. But honestly, I'm not familiar with all the potential use cases for core component models. So thanks a lot for clarifying that. I wonder though, because I'm not sure if anyone actually did like a deep dive into this JCO approach, and are we actually going to be losing anything by doing the transpilate process? Do we believe that the resulting module can be as I don't know, as performant, as high quality as the one that will be produced by, for example, Clang directly?
Yeah, I guess we'll have to ultimately build that to see, but I think talking through it with Alex, we can achieve performance parity, close to performance parity to what WASM time currently does with more ad hoc baked in approaches. The trick is when this core WASM, when we generate the core WASM, the trampoline stuff, we can have that core WASM use special magic imports provided by the runtime that do low-level stuff that normal WASM couldn't do. So we can say, oh, there could be a primitive to load from host memory. We don't want normal core WASM doing that, but this is sort of like correct by construction sort of stuff where we're like, well, we're going to trust this core WASM to do this thing. That's like a thing we can do if necessary. That's like an escape hatch that we have, because this is like kind of trusted code generated core WASM. That's not like the only approach, but this that's a thing we can do is use magic core built-ins that are just exposed by the runtime to this trampoline WASM that we've generated, so we kind of know it's well formed.
Okay. Yeah, okay, cool. Thanks a lot for that. I think it'll probably need a little bit of more investigations before we make the final decision, but at least I'm clear on why this was even proposed in the first place. So thanks a lot.
Yeah, thanks.
Also, I think Stephen had his hand up.
Good. Although I'm feverishly trying to take notes. Lots of great discussion here. I really appreciate this. I think we're all actually saying a lot of similar things. So one thing I'd like to articulate is I think there's a few things we agree on, right? Doing this by hand is dangerous, right? If we just go and make these APIs and it's done by hand, then we introduce, the potential to make errors. So I think we can agree that we want to be able to code generate this. We want to have something like WIT or an IDL that formally specifies this, and it's not arbitrary. So I think we largely agree on that. If we don't, please scream in the comments, and I'll make sure I edit the notes appropriately. I think the other thing we are talking about is really improving the tooling. But I think what's more important than improving the tooling is really articulating how this can work in the context of something that is system level or embedded level programming, right? At the lowest basic fundamental area. I think if we can figure out how to, like, what is this path? What does this look like? Then folks like Chris, myself, and Marcin, and everybody else on this call can start, working on efforts to get there. I think the problem is right now, and I apologize if this wasn't clear in the document, that I think most folks are in this wait and see approach, right? If you look at all the runtimes today, nobody's supporting the component model, right? And in fact, if you go and you look at certain repositories for certain WASM runtimes, there is literally issues that say we're not considering this at this time at all, right? Quite firmly. And I think that's disappointing, right? I spent a lot of time, and it was really difficult. I'm somewhat newer than many here to the WebAssembly community, but I spent a lot of time trying to get a component built and then trying to get that to run. And I wrapped it and I unwrapped it, and lo and behold, I actually got it to run on Wemmer. Didn't quite get the output I wanted because I was getting a component model return, but I got it to work, and so I know we can make this work, right? But I think the path, like how should this work, and that path forward and the documentation around that definitely needs help. I will be the first to sign up to help explain that path forward once we figure that out. And then I think, as Dan was saying, there's likely some tools that could improve that situation, right? Because there's a lot of manual steps we need to do. We can fix a lot of this with tools, whether that's some sort of static step where I take and package the WebAssembly, or I unwrap the component, or I do something like the transpiling approach with Jco. I don't know what the answer is yet, but I think that's part of that solution as well, right? So I'd say three things. What is the way we express this, and how do we express that? It sounds like WIT's okay if we can make that work. What is the path forward in improving the docs, and then also improving what's the ultimate tool solution going to be, right? What's that end state? And now I'll lower my hand.
I think we had Thomas, and I can see Dominic. So Thomas, I think you're up first.
Yeah, can go. Yeah, just wanted to add this aspect of the system level programming. As you already recognize, that this paper is about of how to go forward and how to raise the confidence that other preview states will provide a path to migrate, and not just saying kind of you should never have used it and now bad luck. That's it, stick with it. I think this is not the way that this should be communicated. Way better is, okay, we know this is breaking, we know this is a lot of pain, but we provide means for doing the migration path, right? So not to leave the others alone in the rain when the things are changing, which is inevitable in some sense, of course. That's one thing. The other thing is this kind of system level programming needs, let's call it that way. Someone needs a signal.h, for example, and just needs to use it and don't wants to port it, and just, well, you could use WAMR for example. You could plug in a kind of a native library into WAMR and then export some of the C APIs to it into the WASM world. Yes, there are problems around data type mappings or handling pointers, etc., which is fair enough. You could do so, but it's a lot of pain. So the question is how to port legacy code using signals. Maybe you want to have a system level primitive that you want to ship via an AOT compiled WebAssembly core file because you like the isolation. Think about kind of firmware programming. Yes, you could argue why use WebAssembly for it. Maybe you want to update it without stopping the device. Maybe this should be possible. Another thing is shared memory accesses. We know that this is possible. We can use mmap if we want to. However, this is additional effort, of course. And another thing is, again, legacy support using the boost library, which may raise exceptions, which is still falling behind a little bit. All these things make adopting it hard. And the question is, how could we solve it together? This does not mean that we want to go different routes or use different forks, kind of different WASI versions, kind of. Does not mean, but we need some kind of capabilities of the WASI or WebAssembly world to make system level programming possible and as easy as possible. While not giving up sandboxing, kind of, but maybe to some extent being allowed to give up supporting different languages, or so to have an interaction of languages that have very different APIs under the hood using it. Maybe this is an option. I don't know. So being forced to use everything that a component model brings to brought up this idea of layering the things, kind of having some low-level APIs, low-level primitives, and component model, etc. is really great. It's really fun to use. But maybe on the system level API, you want to have full control as much as possible, but not giving up the sandbox, for example, on this level. These are the concerns that are inside, not only inside Siemens, but inside a lot of stakeholders of the E-SIG. And yeah, we are working on it and trying to figure out how to move on together. And that's why we want to discuss it also inside the Bytecode Alliance and in the wide community, right? We don't want to split it up. However, I have to admit there are also some yeah, kind of diverging activities, naming JavaScript strings, which are more or less optional. For example, another example is relaxed SIMD, right? If you have it or if you have it not, you may have different behavior of your WebAssembly module, depending on what you're using. So there is already some kind of diverging in the standards, talks about profiles, etc., etc. I'm not a fan of it, and that's why I think that this layering approach could be one thing, yeah, to tackle it. Kind of. I'm not sure about it because I'm not very deep into the component model, and that's why I want to discuss it.
Yeah, let me just tag on there, Thomas. This is something that I talked briefly with the technical steering committee with Oscar, Bailey, Andy, and their feedback was in part that sometimes we're not asking the right people or talking to the right groups about how we would go about achieving some of these goals. And that I think is where asking for some support from like Luke or Ralph, or hey, there's a group about this, you should talk to them, right? Or you should get more involved in this. Or if you want to do the tool chain, these are the people that's doing it, and you should talk to them about that too. So I think there's more we can do in the E-SIG to support people, and to get more involved. I think that's the next bit, and Ralph's been alluding to that, and I think some of the chat has been going on about we've got a plan, how do we move forward and start taking action on it, and that will be the next bit. So I can see other people have their hands raised. Luke plus one other, it says. Dominic, I think, was first up. So you must be the one other, Dom.
Yeah, but I don't know, Luke, if you want to react to Thomas first.
Yeah, maybe just briefly. One good thing about all those low-level systems primitives is there's like a small finite number of them, and each one's like a big deal. It really impacts the whole system. So we can kind of enumerate them and say, what is our answer for porting this code, that code, this code that uses this thing, this thing, this thing. And so you have mmap, signals, threads, and I'm forgetting, exceptions are the things you mentioned. Each one of those, I think, has an answer in some state of progress. Even mmap, I think, has a really good answer now that maybe looks a lot like Whammer's shared heaps feature, because that seems to like check a lot of boxes for a lot of people. And exceptions, they've taken a long time, but they're making their way down. And then even signal handlers, there are ways we could express that in a component setting. A thing that a lot of people maybe don't know is, in addition to being able to write interfaces and wits and then generate the bindings, that we want to be the heavy lifting thing that we write lots of interfaces in, like for sockets and file systems and I2C and all the other weird interfaces, all the many interfaces of I/O. Ideally are written in WIT, but we have this other ability in the component model to have what we call built-ins, which are just things that are just low level that only have a core WASM representation that you can just do. And this is the more expensive, the harder to do thing, because we have to be a little more careful about these. They're not virtualizable, so we have to say, how do they compose? But this is our thing that we can do to solve these hard problems. So, signals and threads and mmap, these are like canonical ABI, and then also just even core WASM things. By pushing them lower, these are often cross-cutting things that impact how you do code gen at all, because they're just so fundamental to what it means, like loads and stores, and like what can the compiler assume about what it can optimize, all these things. These are very important features. So it kind of does make sense to push them a lower layer, not just do them at like, oh, those are just API calls. No, that they're kind of a little more magic than that. So we do have a way to address that. It's component model built-ins. And I think if we enumerate the things you said, like each one of them, I think has answers that we could get more specific on. What is the project? Who wants to work on that? And then ultimately see them through. So I do think we could do all of those without having to split off something else than what we're currently doing. So.
Cool. And so, Luke, just on that, where would be the best venue to have that conversation? Is it here, or is there a component model built-in discussion group that we should be joining?
Well, the component models, the things that we're like officially proposing kind of closer to implementation, if we want to brainstorm the solution space, what are the approaches we want? This is a great group. So I'd be happy to participate with that, especially we start with like a list of all the things and say, what is our plan of record for each of these, and then dig into them in more detail. Okay, what do we do in core WASM? What do we do in component model? What's a WASI interface that has a WIT definition, like different answers or a combination of answers for different things?
Cool. And we've got a list of the existing built-ins for the component model already.
Oh yeah, I can. They're in the canonical ABI. There's a component model built-in section that has, you know, and a lot of them look like things you're familiar with, like read and write, pass it a pointer to a buffer, you know, like so. Anyways, stuff like
Awesome. Thanks, Luke. Okay.
Real quick, as the person taking notes, feverishly trying to get everything captured. Can you? Is there a link to the detail around built-ins that you can share, Luke?
Totally. Let me do that.
I think that would be helpful.
I'll paste it in the chat.
I've heard them spoken about a couple times. I've seen some details, but I'm not sure everybody has.
You bet. Totally.
Okay, I see loads of hands up. I got about 4. I think Dom, you gave way to Luke there.
Yeah. Yeah, it's only 10 minutes left, so it's let's see. So thanks, Luke, first for elaborating on the built-ins. I think this is something which sounds cool. So I always have this in mind. So when we design embedded systems, we try to obscure the hardware closeness as good as possible for most of the application code, and then we have things in like critical sections and so on and so forth. So parts where we cannot be obscure and where we need to have direct access. So maybe build-ins is a way forward. I wanted to pick up one of the first thing you said, so I waited quite some time if somebody else would do it. So I totally agree with you that we should have a common goal and take a step towards the common goal. From a guy who's often in the mountains, sometimes a step to the side is a step in the right direction. So I don't want to create a false sense of urgency, but as Stephen said, people are in a waiting position right now and deciding if they want to build their solutions on what is out there, which is P1 right now. So and maybe it makes sense and it's a viable approach to have a side step to fix the P1 for us and then take a step towards. So I don't see it as a discussion either or. I just see it like let's say an extended a scenic road or something like this. So just my 2 cents.
Cool. All right. We have I don't know who was up next. Christoph Pettik, perhaps.
So I just wanted to ask Luke whether he has an idea about using the JCO approach for basically getting the glue code into a more standardized way would help 0.3 as well. Because I see people currently struggling implementing 0.3 and JCO and WASM timer implemented independently. At least that's how it looks to me. And I'm just curious on whether this approach could also help there.
I think yes, totally.
And there's something I don't think is mentioned often enough. It's this compiling the WASI P2 to an core module and using the 0.2 interfaces. I think there's a proposal for standardizing these imports and exports even for a core module, which is using the CM32P2 pipe prefix. And so if you see something like that, that is basically about using the WASI P2 with the core module.
Okay, cool.
I'll find a link and drop a link to that in the chat so people can see it. Because yeah, and then that's what Christoph was just saying.
All right, Ralph, and then Martin, I think.
Martin can go first.
Okay, thank you. Yeah, just wanted to also touch on the built-ins that you mentioned, because so now we have the shared everything threads proposal, and I think there is a need for a built-in to spawn a new thread. At the same time, I think the shared everything proposal is a proposal for the core WASM. So does it mean that the core WASM now is taking a dependency on component model?
That's a very good question. It's Ideally, there would not be a thread.spawn in the component model. There would just be a thread.spawn instruction in core WASM, and that is the long-term goal. The problem is that's a lot more work for browsers. They're kind of happy with the current setup where threads equal workers, and they spawn a thread pool of workers. And so what they would like is the core WASM just calls out, and either on a browser, it does a workery thing, or if we're in outside the browser in a component model setting, it's just a built-in. So it's only dealing with timing and effort and browser willingness to do things in what order that we have thread.spawn being an import. So but the way the dependencies work is core WASM doesn't care where the threads come from. They just say when you have a thread created by the host, here's how multiple of them can run and interleave and lock and all that stuff. And the shared attribute that allows them to share function tables, which is the key thing that we get out of shared everything, is share function tables so we don't have to have this quadratic blow up of space. So core WASM doesn't care how you create the thread. For the time being, eventually they'll add an instruction, or at least that's what a lot of people in the committee wants. And once the browser up for it, we'll add an instruction, then it'll be redundant with the core model, the component model built in. And that's fine because it'll just be a tiny wart, and we'll implement the component model built in via the instruction, and it'll be fine.
Yeah. So I think this is my concern here. So should we basically put the standardization of this on hold and leave the sort of that detail how spawning the thread is defined? So just not put it into the standard, because I think it will have significant implications if we let this to happen, because then, I see it in the standard, I see it has dependency on a component model, and what I think first is, oh, then okay, my runtime needs to support.
Oh, well, the browser's being diplomatic there. They're saying, hey, if what you want is to run outside the browser, here's your answer. The browser standard doesn't depend on the component model. They would ship it without the component model. And just saying, oh, the core WASM will just import this function, and the toolchain will just emit a call to an import. And on the browser, we'll implement it with JavaScript that does whatever it does today. And outside the browser, we'll implement it natively. So it doesn't, they're not taking dependency on the component model, even though they kind of list it as the solution to this question.
And
Sorry, go ahead.
Yeah, just to point out that immediately following this call is the thread subgroup is going to have a call. So if you're interested, I know I talked to Thomas Lively and Conrad and Andrew Brown, and they're all like, hey, come along and join the call. We'd love your input on exactly this issue. So more than happy to go along. Invites there for us. But part of this is making sure we talk to the right people about the right things. So it's there. Ralph's had his hand up for a long time, so I was just going to.
Well, I mean, actually, this is good timing, because at this point, I think that there are things that we could all pursue that drive toward the primary goal, which is trying to figure out how we jump the chasm between here and there, right? Which everybody sees right in front of their face. That part's easy. I think one of the things that will build frustration, and probably has, is that unless some of these ideas are actually tested out, and that requires a human to write code, then we continue to meet, but we'll also be sitting there going, when is this happening, kind of thing. And the problem with those environments, that the environment we're in, is everybody's resources are constrained. I don't know which of the people here are not working on AI, but I'd love to know who that is. So I think one of the things that should be a follow-up for async is try and figure out which one of these ideas, some of which are very good and tackleable as a test case of going forward, of trying to make progress for everybody, is something that someone can find a human to try out or start trying out. And I don't necessarily think that's a thing that needs to be figured out in the next 2 minutes, but is a great target for the conversation in the Zulip or somewhere else, an email or on an issue or whatever it might be. But I think that thing, like how can we map these ideas to say bits that we can run and see where that gets us, is going to be the next thing that we stumble into because otherwise people working on the component model, for example, are busy doing the JCO thing and doing the WASM time thing, or trying to match things upstream with async and trying to move, you know, like there's so much to do that it'll be really easy for those people to not work on this. And in a month, we could have the same conversation because we don't see steps being taken. So I think that's probably important as a way to move forward.
Yep. Stephen, you had your hand up.
And I'm on mute. I agree. I think having calls about it and discussing it ad nauseum is just going to build up frustration, and it will be exactly where we are now, where people are in the wait and see moment. And I think we all collectively want to move from that, right? So to that end, Ralph, and to something that Luke said earlier, I think probably the next best step for us is to articulate that list of things that Luke was talking about, right? And very concretely, here's like the things we need to kind of move forward. That's stopping our collective folks from moving forward. And maybe that's what we build up and then talk about in the next call. Then we can prioritize that and pick off, maybe not the top thing, depending on what's most achievable in a short period of time, but pick off one or two of those things, as Ralph said, and start attacking them and making some progress on that and moving the ball forward. Because I think there's a lot of discussions around this. There's a lot of things that are theoretically possible, but to Ralph's point, if we don't make progress, then they're just theoretical. And then we're just arguing slides or my point versus your point. So does that seem like a reasonable next action for everybody? Nods.
Makes sense to me.
Yeah, we gotta have to start with the list first.
Yeah, I think one other thing too, different than what I just said too. I think another action item out of this as well is I think the confusion that we had with this document around the component model details. I think that appendix would just remove, because I think it's probably just causing people confusion, and I think it sort of gives the impression that we're trying to say, hey, we want to do something different for not have the component model. That wasn't necessarily the intention there, right? It was more about, hey, how do we layer this out? How do we organize that? And so I think that discussion in the document probably is just causing more confusion than good. So if you're okay, Chris, should we just remove that so we're not, because there's a bunch of people who are not going to be in this call, may not see this recording and may not get that context.
Well, if I may jump in really quick, I have no problem if the introduction lays out what the objective is a little bit more clearly. I have no problem with anybody that just says, hey, component model 1.0, we're talking 2026. Maybe it slips, maybe it doesn't, like that's a ways away. This document is about how do we get there with the stuff that we have now. And then you've framed the whole conversation, right? Like, it's just about like framing. I don't even think the content, there's nothing wrong with the content per se, although there's some details that, can need to be, fleshed out there. But really, it's just framing. What are we doing with people who have Preview 1 in small embedded spaces that enables them to move forward, hoping and engage with the component model as it evolves towards something they can support? Remember, it's totally fine to say, hey, we get to 2026 and it turns out the component model is not going to do what they need to do in 2026. And if that happens, then the component model is not going to occur for those people anyway, right? Just as a matter of business. So we don't have to sit there and say anything about the component model getting there or not getting there. We have to say, what is it that we are doing now that gets us that direction, that allows us to take advantage if it appears and gives us what we really want, right? When it appears, but keeps us in business. That's the perfect framing. And then the content can be, there's some modifications we can make. We can, blah, blah, blah. But you can even leave the component model stuff down there later. Cheers, Emily.
Yeah, let's take that. I'll take that one as an action to add some extra framing. We are over time by 3 minutes, but I think it's.
I'm out.
Really
Love
good.
you all. Cheers.
Thanks,
Take
Ralph.
care.
Thanks, everyone. Thanks,
Bye.
all.
Bye, guys.